The topic is continuous wave obturation. Continuous wave obturation was invented in 1986, typically a dissatisfied dentist. And it was me. I was using Schilder technique, which was fabulous in terms of filling lateral canals because we had virtually no other technique that would accomplish at that time. It was taking a long time and even more difficult than the time it took us clinically. It was harder to teach than any of the other techniques. And so my design of this device was intended to replace three to five pluggers and a heat carrier. Whether it's an electric heat carrier or a flame heated heat carrier. So we have 4 to 6 instruments, and instead we have a single continuous wave electric heat plugger. Okay, let's see what that looks like. Basically, these are very clever devices. They have a taper to them. They are all 0.5 millimeters, their tips. The taper varies. And those are, we have 06, 08, 10, and 12 tapers. They're continuous tapers for 16 millimeters. So these are the 4 sizes here. Now in general, we'll come back to this, but in general, with traditional techniques and fuller shapes, we're going to use the 6 or the 8 for small canals and the 10 or 12 for larger canals. Current trend in endodontics is towards smaller coronal shapes, and so in my practice I'm using the 6 for small canals and the 08 plugger for the medium and large canals. The clever thing is these are basically hollow stainless steel tubes, and inside that is an insulated copper wire through which electric current goes up to the tip. There's a little solder joint here, and the ground is this direction. This is stainless steel. It's resistive to electric current, and that's why heat flares at the very tip of the plugger within 0.5 seconds. We have a spike of 300 degrees C at the tip of the instrument. This has a feedback system so that we can track that. So on to the method. Okay. Preparation, taper prep, fit a cone. You can also do with these a standardized stop preparation. You're going to use a narrower plugger. So we're going to pre-fit the plugger. If this is a central incisor, I'm going to call that a large root. So I'm probably going to start with a 0.12 continuous wave heat plugger. And I'm going to pre-fit it in the canal. Remember the geometry, it's 0.5 millimeters at the end, and it's a 0.12 taper behind. If this happens to be a big central incisor canal, a young patient, that plugger may fit all the way to length. However it fits, we're going to put it in the canal and wiggle it to allow the canal to bend it because it's dead soft stainless steel. We pull, and then when it meets its binding point, we adjust the stop on the shank so that we are at the reference point, and then we know where it's going to bind. We then compare that cone, we compare that plugger to the cone we fit. The cone we fit has a pinch mark on it. We put the little stop on the plugger next to the pinch mark on the gutta percha, and we'll see how close the tip is to the end of the root canal. And what we want is pluggers to fit within 4 to 6 millimeters is ideal, but if you get less than 3 millimeters, you have trouble. Okay, because if you have a cone fit here and you down pack within 3 millimeters, heat transfers through the remaining gutta percha, it'll soften up and squirt through there like an extrusion. So you've got to check with the big canals to make sure the pluggers fit Not too close. If it is too close, you simply move it back to the 4 millimeter mark, adjust the stop, and then you're ready to go. For that case, I'm going to always do a single cone backfill. Okay, we'll talk about that more in a minute. So the cone is cemented in place, and it's been fit 1/2 millimeter from length, because during the obturation process, it's going to, sorry, this is really hard to draw. It's going to scoot 1/2 millimeter during the down pack phase. We take the plugger and we insert it alongside the cone and hit the button and drive down through it. As the plugger gets near its binding point, we're going to let our finger off the button. And as I'm down packing, I'm watching the stop on the plugger getting close to the reference point. And when the stop on the plugger gets 1 millimeter away from its binding point, I'm going to let my finger off the button. I'm going to continue pushing, and of course I'm going to end up somewhere around here. At this point, all of the lateral canals are filled. We have cute little puffs here. Everything in the canal, primary canal, we might have a little cute puff there. And we have a place, the plugger's in place now. We have two options. We can do a separation burst of heat. And what that is intended to do is to flare a heat pulse through there that heats the plugger tip and the gutta percha next to it so hot enough so that the gutta percha right here can't hold together. When we retrieve the plugger from the canal, the gutta percha will be glued onto it and the apical mass will stay there. Now if you have a huge canal, we're going to do a longer separation burst. Typically it's 1 second heat and then 1 second pause, and then we withdraw. If this is a really large canal, then I would do a 2 second heat transfer and then a 1 second pause and remove it. If you have a huge canal, tip of here is only 0.5 millimeters. If the canal is 1.5 millimeters or 2 millimeters wide, it takes longer to heat the gutta percha near the plugger tip enough so that it will not pull the master cone from the apical third. Now, one thing I haven't mentioned is how the sealer is applied. I alluded to it, but we have a cone, and I'm going to dip and coat the tip of the apical half of that fit cone. The canal's dried with 3 to 4 paper points, and I also use paper points to confirm length. That's a different topic, but we're going to carefully take this sealer in. I prefer Cyberon pulp canal sealer. And I use the pulp canal sealer. I use it for both filling techniques that I do, both center condensation techniques. I use it thicker for a continuous wave technique because I want it to be a little bit stickier. It'll help hold my cone in place so I don't pull it out. If I use it for center condensation, I'm going to mix it thinner because it's got to have a higher flow rate to escape the canal. So when we mix it a little thicker here, it can raise off the pad 1 inch on a spatula and not move back. That's how you know you're ready to go. It's a 2-part system, powder liquid. If you're on mixing for a carrier, then it's going to barely go up 1/4 inch and it will drop back immediately. Okay, so that's sealer. Because we're mixing it thicker, be careful when you first put it in. If you jam it in there, you will accelerate its movement through the canal and have unnecessary surplus. Surplus is not a concern, but you know, less is usually more. So now what we have is, let's say that we did the separation burst. Okay, we have gutta percha to here, and it's empty the rest of the canal because we have done a separation burst for 1 or 2 seconds, pause for another second to let the heat radiate through the gutta percha, pulled it out with all the gutta percha in this part of the canal on the plugger. So we call this the backfill space. And the things that we're going to backfill with, we can syringe fill that, use a gutta percha gun. That's the ones we pull the trigger by hand. These are all heated gutta percha. We have extruders. Those are the electric motor-driven versions. And we have also single cone backfill. You can also use compactors for backfilling. What that entails if we're using an extruder or a gun is to load the gutta percha in the gun, wait till it heats up, advance the piston forward so we have gutta percha coming out the needle, place the needle in the canal and wait a full 5 seconds. If you put the needle into the canal and pull the trigger, you're going to have a less ideal, a less consistent result. Once the needle needs to be probably 120 to 160 degrees at the end for the gutta percha to come out correctly. And when we touch it to the patient's body, they're 37 degrees C and we need to be 125 to 140 degrees C. So what do we do? Because it's going to chill the needle when we put it in there. If we just wait, more heat drives through the sterling silver needle, reheats the needle. We've imparted heat to the canal wall and the apical mass of gutta percha. So everything's warmed up. It's going to glue together better. We're going to then pull the trigger or push the button on the extruder and wait until it bumps the needle back. Use heavy body gutta percha or Reslon. And when it bumps the needle back, we're going to remove it immediately, take a plugger in there, usually a 0.7 millimeter plugger if it's a small canal. Any plugger that will fit and condense the apical mass of gutta percha. Then you're going to put the needle back on it. You will now have the needle on the gutta percha. Wait another 5 seconds. I will usually let it push me out to the orifice or a millimeter above. Do a little circular motion after a couple seconds. Pull it out and then condense. Condense a millimeter short of the orifice ideally. Dang. Because I want to put a secondary filling material in here like glass ionomer, even Cabot, before I put my bonded composite restoration in. There's a second way to do backfilling, and that is single cone technique. The way that's done is when the down pack has been completed, meaning we have the plugger at its final position, 1/2 millimeter from length. Oh, that was a little rough. Instead of doing a separation burst, we wait 10 seconds so the plugger can cool down, because until it cools down, the gutta percha will still be glued to it. We want to disattach the plugger from the gutta percha and leave the gutta percha exactly where it is. 10-second wait. We push apically. And we rotate the plugger to break it loose. And then we tease it out. We're left with a space the exact shape of the plugger. And the apical region of the canal, it's a little tough to draw in here. The shape of the plugger, we can match that with a backfill cone. It's 0.5 millimeters at the tip. It has the same taper as the plugger did, and we coat that with sealer, and we simply put a backfill cone into the space, move the cone back and forth, pull it out, make sure it's coated to the end. If it's not, put a little bit more on there, take it to place. We then use the electric heat carrier and we sear it off at the orifice, condense there, and we have the whole canal fill. Single cone backfill is not commonly used, but it's really effective. Basically, that's how I do all my backfills for medium and large canals. It takes much less time than syringe filling. Very unlikely to get a backfilling void. A little less expensive, not that that's a big deal. And single cone backfill, this is the best way to remove a void. And I'm going to talk about that in a different topic. Another way you can do that is with a compactor, a rotary compactor. Talk about that later. We have a topic on eliminating the voids. Okay, if I write a list of avoiding the void rules, what are the things I'm going to consider? I'm looking for a flat interface at the end of the down pack. When I down pack with the electric heat carrier, stop, separate, pull it out, and condense that little apical mass, I want that to be flat. If that looks like this, and this is the gutta percha in there, and I have jammed it with a plugger so it looks like this, that will then be a void when we go in here and try and syringe it. Okay, so the way you know that happened is you have a cylindrical void. Weirdly enough, it looks kind of like the tip of your plugger. So the answer to that is use pluggers that are better sized. If you're in a medium or large canal, you're going to need a bigger plugger. In small canals, not such a big deal. Another thing that I'm going to pay attention to is the 5-second wait. With syringes, if you don't do that, the needle touches the canal wall, 37 degrees, it becomes chilled, the gutta percha inside is chilled, and it rolls out of there less thermoplastic than it would if it was at a normal temperature. 5-second wait allows more heat to drive down the needle, and we get a better molding of the material. Pulling the extruder out, pulling the needle out. Okay, we want to put the needle in place. We want to start after 5 seconds, hit the switch, and leave it there. In a small canal, it'll be binding the canal, and the apical mass will be beyond it, so there'll be a vacant space. In this kind of a canal, a larger canal, the needle may be right on it. It doesn't matter, but we syringe until we feel it bump the needle back. That's why we want heavy body material. But if you become impatient or don't know better and you start you hit the button or you pull the trigger and you're syringing and at the same time you retract the needle, then in that case you will get a void that looks like this. Okay, this void is like a string. It's strung out because the needle was prematurely pulled.